The way we are going to proceed is we are going to freeze our body. Now this is kind of important because the way any feature-based modeling software works is if we created another volume around this and just extruded a huge cube or something around this body, it would merge the two parts together. So we want to go to Tools and Freeze. Now this body is frozen, and if we create something around it, it will be two separate bodies. So that's what we're going to do. The way you do this, the easiest way probably, is to create an enclosure. So Tools, Enclosure. What this offers us is a new menu. You can pick a shape. For kind of vehicle aerodynamics, you would like to use a box because it will be most similar to a kind of a wind tunnel or something rectangular and stuff like that. If you're using, if you're trying to do CFD analysis on something like a helicopter or an airplane or something like that, a more appropriate far field would be a sphere or something like that, where you do not really need a wall that is going to represent the road and stuff like that. So, but we're going to remain with a box. The next thing is the number of planes. So what this means is the number of symmetry planes. Obviously this body is symmetrical down the middle, so obviously you would choose one symmetry plane, and then you would say the symmetry plane is the YZ plane. So you would click YZ here and apply. The model is a full model. If we already cut the model in half in SolidWorks and set the symmetry plane to YZ, we could pick partial model here, and the DesignModeler will recognize on which part of the plane, either in positive X direction or the negative X direction, where the material is, and it will create the enclosure on that part. But since we have a full model, it will cut it in half for us. So we're going to use one plane for now. I mean, we're going to need two, but I'm going to show you why we are going to use one for now. So we click one, and next thing to choose is a cushion. Now let's say, well, cushion is basically the amount of air that it's going to provide away from each surface of the body. So I'm going to demonstrate this rather than talk. Let's say 50 millimeters and generate. Okay, and it created a volume of air which is 50 millimeters away from each surface of the body. So from the bottom surface of the leg, from the side surface, and from the top surface. Now we obviously don't want our domain to be uniform, because we want to have, let's say, 5 car lengths in front of our body, 10 car lengths to the rear, 5 to the side, or 5 to the top, and stuff like that. So we are going to go to enclosure and edit our selection. We are going to go to non-uniform, and now this is the problem that most people face and don't really know how to fix it. I've been asked this on the CFD Online forums, and this is why I'm doing the video. So you can say, for example, in our X plus direction, this is to our side, our body, people usually say it should be around 3 to 5 car lengths to the side. So let's just, our body is 1044 millimeters, so let's say 3000 for now. If you click generate, you can see how this looks. Okay, and then our Y plus, we are going to also put 3000. Generate. You can see how that looks. This is the kind of zoom to fit button, so I like to use that one. It's also available in the right click menu. And then we want our domain to extend in the positive Z for, let's say, 5000 millimeters, and the negative Z, let's say 7,500. We're going to be cheap. Okay, but now you're going to face the following problem. You do want the legs to be in contact with the road. There needs to be an intersection there. So if we look at it from the Z plane, and I try to put in the Y direction, in the negative Y, I'm going to try to put 0, obviously, to get an intersection, but it does not allow you to do that. Now, the way to fix this is we are going to say we have 2 symmetry planes, okay? Even though the body is not really symmetrical compared to the ZX plane, this does not mean that the symmetry plane means that we have to mirror the body. It just means that we can get our intersection working. So we're going to do enclosure, edit selection. We're going to put 2 planes here, And our other plane is going to obviously be the ZX plane. So ZX plane, apply. And now it does not matter what you put in the negative X direction, negative Y, I'm sorry. In the negative Y, we can put 50,000, okay? And click generate. It does not matter. It's going to intersect our legs perfectly, okay? So that's kind of good to know. Same goes with the symmetry in the negative X direction. It does not matter, and yeah, and the Y. So this is kind of how you get your volume of air. Now it's created another body here. It's named it a solid, and it is a fluid body. So we're just going to rename this into our air, because that's what it's going to be. The next thing to do would be to kind of subtract our AMAT body from the air, because air is this whole cube around the body. The air is also here. So we're going to do a create boolean, and this is going to offer us a unite or subtract or intersect or stuff like that. So we're going to subtract. Our target body is our air. Okay, so click anywhere on the air domain. And our tool body is going to be our AMAT body. So you can either click here, or you can select it from over here and click apply. And do we want to preserve our tool body? We do not want this solid. It does not have any purpose for CFD other than, for example, fluid structure interactions and stuff like that, but we can cover that in the future at some point. So this is what we end up with. Okay, you have the air without the AMAT body. So this is just the air, and this is what we actually need. All of these surfaces, if we pick the selection tool here, all of these surfaces are going to be stationary walls, okay, inside Fluent later on. So we are going to pick all of these and say it's a stationary wall. Well, we're not going to pick it because Fluent is going to know. So this part is kind of done. There is still a step to assign named selections for velocity inlets, pressure outlets, and stuff like that, but I like to do that inside the ANSYS meshing. So for now, this is kind of ready. So we're going to save our project, and we're going to go and save it in the tutorial folder under AMAT body. One thing I would like to mention is keep all of your files in the same folder. So if you're doing a project, create a new folder and name it my project. Inside, okay, I've obviously mistyped that. Put your SolidWorks geometry if you're doing an import, or CATIA geometry or whatever. Put everything inside here, including the workbench file and the associated files it's going to create. Because what's going to happen if, let's say, your AMAT body is somewhere on the other hard drive and you move it later on, the whole project is going to fall apart, and you're going to have to look for the body and stuff like that and try to fix that. I've kind of ruined 60 gigabytes of my files just by moving a couple of files, and I've not been able to repair it. So keep everything in the same folder. Okay, that's it for now. I'm going to continue recording, but this is going to be in another video. So bye bye.